Spectroscopy is the science studying the interaction between the electromagnetic radiation and matter, in our case, the vegetation. And among the optical properties, we focused on the reflectance, so the amount of radiation reflected from the vegetation. So by using digital tools, as you can observe in this slide, we can obtain an input represented by the hyperspectral profiles or signature, which we can exploit to monitor the plant response to biotic and abiotic stress. In particular, this kind of digital tools is able to provide hyperspectral profiles which cover all the electromagnetic radiation, ranging from the visible band, near infrared, and shortwave near infrared regions. How can we exploit the hyperspectral data? We have three different approaches. First of all, we can apply vegetation spectral indices, which are really simple and intuitive to use. But in addition to this approach, there are other approaches which are more complicated. For example, we can apply prediction models. In our cases, we use the partially square regression models to estimate some of the most important leaf traits that can be impaired under biotic or abiotic stress. And lastly, we can perform the analysis of spectral signature. So we can assess the plant spectral responses to stress, and we can monitor the crop status over the time. The experimental trial was conducted in the free air ozone exposure facility based in Sesto Fiorentino in Tuscany, central Italy. We used the genotype Cabernet Sauvignon during the subjected to three ozone concentration: ambient air, moderate ozone, and elevated ozone. The measurement of physiological parameters was made using an infrared gas exchange analyzer, and spectral collection was performed with full-range spectrophotometer during the spring-summer 2022. In particular, we measured the physiological parameters, and we collected hyperspectral data at two phenological stages: bunch closure, BBC age 77, and berry ripening, BBC age 83. Why? We wanted to develop PLSR models to predict key functional traits which are largely investigated into the ozone and plant interaction. We wanted to evaluate the capability of hyperspectral data to disentangle the ozone, the plant responses to ozone stress. And lastly, we wanted to investigate the variation of photosynthesis estimated by the spectra, and the variation of two spectral vegetation index related to chlorophyll content and water dynamics. Moving on to the results, here you can see the PLSR models we developed to predict these traits: net CO2 assimilation, the transpiration, the mesophyll conductance, and the carboxylation capacity of ribulose 1.5 biphosphate carboxylase oxygenase. It's interesting to note that for the prediction of these parameters, we use not only the full range spectra, but also the spectral range related to the shortwave infrared region. Let me point out that we tested different spectral range, and we obtained the best goodness of fit, as you can see here. As you can see here in the graph, by using these spectral ranges.